Okay. Permutations and Venn diagrams. So this is somewhat of a complex question. We'll just take the major points here. There's 10 people at a rectangular table. Tanya must sit at the head of the table, and Henry cannot sit beside Wilson or Nancy. So we've kind of drawn it out. We have Tanya here. We assume this is your rectangular table. So if there's one head of the table, there must be another one over here. Doesn't matter who sits opposite her. But we have this guy, Henry, here, and he cannot be beside Wilson or Nancy, which makes this interesting. Okay, we have to consider a lot of different options when doing this. When you do OR, the idea is that you need to, okay, first of all, let's calculate how many options are. Let's start with that. So we know 10 is at the side of the table. That gives us 9, let's see, 1, 2, 3, 4, 5, 6, 7, yeah, 8, 9 other options around here, okay? So it'd be a permutation or just a straight factorial. You could say it is 9p9 for the number of options, or 9 factorial. They give you the exact same thing. I think they've already calculated it. It's 362,880. So 362,880 options. But that's assuming that Tanya is at this one. So she might also sit over here. And that would double everything. So we're going to multiply this by 2, okay? Because if Tanya sits at this side, that doubles all of our options. Everything goes up. And we're at, what did we say for this one? 725? Something like that?
Yeah, 725, 760.
760. Okay. So these are, that's a lot. That is a different number of options with just the 10 stipulation. Okay. Now, we got to figure out what to take away from that. Those are all of our possibilities. But now we have the issue of Henry. So first of all, we don't want Henry to be beside Wilson or Nancy. Okay. And there's a possibility he could be beside both of them at the same time. So we're going to calculate that one first. We're going to think of it like this. Can I move Henry? Oh, I could. So in order for him to be beside both Wilson, I'm going to have to do this, beside both Wilson and Nancy at the same time, he'd have to be in between. So now what we do is we kind of count this as 1, 2, 3 spots. We count this as just one unit. And that one unit moves around the table, okay? Which means if we count that as one unit, those are 3 spots that are gone. There's now only 1, 2, 3, 4, 5, 6, 7. There are only really 7 spots to deal with at the table because they must be beside each other. Nancy must be on one side, Wilson must be on the other. So in terms of what we're going to be subtracting, I'll put it in red here. We're going to be subtracting how many ways we can do 7p7 or 7 factorial. Okay, and that's if what we have here is Wilson's on the left and Nancy's on the right. I could, this is my only way of doing it, I could flip that and have Wilson on the right and Nancy on the left. In other words, all that does is just double our number of options, right? So it's going to be 2 times 7 factorial. So let's figure out what our 7 factorial is here. 7 factorial, 5,040. Okay, so that's 5,040. And because there's also the option of being on the other side, we're going to have 10,080. 10,080 options of when they're directly beside each other. Okay. Now, this is where it gets tricky. It gets tricky here because we have to figure out the other possibility of when we have to figure out the other possibility when Henry is beside Wilson and not beside Nancy, and vice versa when Henry is beside Nancy and not Wilson. And what that means is we could couple Henry and Nancy together. I wish they were separate. I'm just going to redraw them now. Okay. We could couple them together. There's our Nancy. So good at drawing. Okay. We could have Henry beside Nancy. Okay. And we could couple them as one unit. So think of that as like an 8 factorial because there's only 2 of them together now. I'll show you what that would look like. Okay, let's get rid of this. So now it doesn't really matter where Wilson is at the moment. We say that, oh, okay, what about Henry and Nancy? Well, you might end up going beside Wilson also. So we can couple them as a unit. So that would be, this is one unit together, which means we then have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that'd be 8 factorial, trying to figure that all out. But the problem is, within that 8 factorial, Wilson, at some points, is going to be on the other side. And we've already counted for that when they're both together. Okay, so what we're going to do is we're going to figure out all of the possibilities where Henry could be beside Nancy, all of the possibilities when Henry could be beside Wilson. So those, again, are both 8 factorial and 8 factorial. That's how many options left. And then we're going to subtract our total amount of when Nancy and Wilson are both beside Henry. So, and I'm going to show you why that all kind of works out. So if Henry and Nancy are beside each other, we'll call it Henry and Nancy. That means there's 8 options, so you have 8p8 or 8 factorial. Okay, and you have Henry and Wilson together, 8p8 or 8 factorial. Let's figure out what these two are. 40,320. Okay, so there's 40,320 ways that could happen, and 40,320 ways that could happen. Okay, but in those, I'm going to show you what's happened here. Let's use red. There it is. In here, we're also counting. I'm not going to add it, but I'm going to say also. We're also using when. Who's the guy in the middle? I already forgot his name.
Wait, can't you multiply both those by 2?
Yeah, you can. You can just multiply by 2. We're going to add them together, which is the same as multiplying by 2. But I want to show you what's happening in here. In this, what's happened is we've counted when Henry, Nancy, and Wilson are all beside each other. So we've counted the Henry. Is it Wilson's the guy in the middle? Yeah,
Wilson,
okay.
Nancy.
And Nancy. We've counted all of those within here, and we've also counted when it's Nancy, Wilson, Henry. They've all been included in this one, and they've also all been included in this one too. Okay, and NWH. Okay, so what's happened here is our total, which was 10,080, it actually has to be subtracted like twice from these because we've double counted it. Okay, so we've double counted this option here. So first, let's put these all together and see what our total is. Our total here looks like it's going to be 80,640. So it's 80,640 different ways that it could be just Henry beside Nancy or Henry beside Wilson. Oh no, it's Henry supposed to be in the middle. I got the wrong name in there, but that's okay. We got the idea here. But these have been double counted. So I have to actually subtract. Now this might stand confusing. Maybe we should get some acronyms here. Let's give me a second. I'm going to put this all together. Got this, and that's why this part was double counted here. We did Henry, Nancy. We got to do Nancy, Henry. It's still going to be 8 factorial, 40,320. But this is when, actually maybe I should change these acronyms here. It's still going to count when Wilson, Henry, Nancy happens, and it's going to count when Nancy, Henry, Wilson happens. And then on top of that, we got to double the bottom one too. You're right. We got to count when it's Wilson on the left and Henry on the right, which again is 8 factorial, so 40,320. But it's also including, we had Henry, Wilson, counts when Nancy's on the left, and Wilson, Henry, when Nancy's on the right. So we got to eliminate those options from each. And those options for each are 5,040 each time. So think of it like we have to subtract 5,040 from this option, 5,040 from this option, because we've already included them in our 10,080 here. 5,040 here, and we just subtract our 5,040 here. So put all these together. It's actually like a times 4. Let's just do times 4 here. 40,030, 320, sorry, times 4. 161,280. 161,280. Okay. And then in order to not, because we're going to add this 10,080 to this number, and then that's going to be like the number we subtract, we do got to eliminate all of these double counting because we've had this, and this double counted. So we have to subtract 5,040 times 4. 20,160. So 20,160. Or was it 21? Did I read that wrong? 20,160. Okay, so in order to get rid of all of the double counting of when they're all beside each other, because we've already included it here, we're going to have to subtract it from this number. This is a lot of extra subtracting. 20,160. Subtract that value. So 161. Oh, it's right here. 161. Subtract this. Gives us, okay, 141,120. 141,120. Okay. Now, this is that doesn't include this value, which we're going to have to add to it. I'm going to have to recap this at the end because this already seems confusing. 10,000. What's that number? 80. Add this on top of it. And all we're really trying to find out right now is what number to subtract. So this looks like 151,000, 200,000. Those are the possible solutions to how many ways Henry can be beside Wilson or Nancy. Okay, so now we have to take this value and subtract it from our 725,760. Okay, so let's organize this. So this is the amount we need to subtract, and the original number we started with was 725,760. So we'll subtract the two. Seven, 2, 5, 760. Subtract our 151, 200, which means the number of different ways we can sit around this table is 0, 6, 5, 4, 7, 574,560 different ways. That is a lot.